And now, you might notice that we did not mention ever the bottom right, this big image that we just talked about, which seems that it has something to do with math and angles. We're going to talk about it right now. It is about visual glide slope indicators. It is part of the runway lighting system, but it's so important, so we're going to mention it right now in a completely different system. So, visual glide slope indicators are meant to give pilots a visual guide during their descent in order to maintain a stabilized approach. You may refer to other videos talking about ILS landing to be even much clearer about the ILS landing and the vertical reference we just talked about. They come in two types. One is called VASI, V-A-S-I, and one is called PAPI, P-A-P-I, each of which has multiple types of arrangements, but both of which give pilots a good idea whether they're on glide path for a stable approach or not. First type is called VASI, V-A-S-I, or Visual Approach Slope Indicator, are bars of lights on the side of the runway that, when illuminated, give pilots a visual indication of whether their aircraft is too high or too low on the approach. VASI can be made up of 2, 4, 6, 12, or 16 lights, usually located on 2 or 3 bars, near, middle, and far. 2-bar VASI provide an indication for a 3-degree glide slope, which is typical for what should be flown during an approach, a 3-degree glide slope. In a common 2-bar VASI system, a pilot should see 2 red lights on the far bars and 2 white lights on a near bar. That's what you are seeing right here and right here on the right image. If all lights on near and far bars are red, as you can see down here, bottom left, that means the aircraft is too low. If all lights on near and far bars are white, that means, just like the top one, that means the aircraft is too high. The rule of thumb pilot use is red over white, you are all right, to tell that you're just on the 3-degree glide slope. The next one is called PAPI. PAPI stands for Position Approach Path Indicator. PAPI lights are arranged horizontally and typically include 4 lights that can be red or white, depending on where the aircraft is on the glide slope. A typical PAPI system, which is really, really common, used in big airports right now, it is located on the left side of the runway, the relative to the side that you are approaching. When all 4 lights are white, the aircraft is too high. When it descends onto the glide path, the light on the right side will begin to turn red. When an aircraft is on the precise glide path, the 2 left lights should be white and the 2 right lights should be red. When 3 or more lights are red, it indicates that aircraft is too low. Okay, so now we're coming back to this image as you see here at the bottom right of your screen. If you get 4 white lights, you will see that you will get theta plus 30 minutes, indicating that the theta here is the approach slope, which is 3-degree glide slope if you're flying 3-degree glide slope. And if you're 30 minutes higher, then you will get 4 white lights indicating that you're too high. If you're within 10 minutes and 30 minutes higher than the ideal approach slope, you will get 3 white lights and 1 red light telling you are a little bit too high. If you're within plus or minus 10 minutes, you will get 2 white and 2 red telling you you're just fine. And if you are lower than 10 minutes, then you will get 3 red lights telling you are too low. And if you're even lower than 30 minutes, you'll get 4 red lights. Remember that red lights in airport or on runway, taxiways always means stop or caution. So flying low is way more dangerous than flying high, because you can always go around and do it again if you're flying too high. But if you're flying too low, then you might cause some accidents or incidents. So you don't want that to happen. That's why white lights indicate flying too high, and red lights, which gives you cautions, indicates flying too low. Okay, what you're seeing here is another system that's not part of the runway lighting system, but it's part of the approach landing system. So, first one, snow lights. Snow lights stand well above the average level of snowfall marking. It marks the runway edges when other runway lightings are buried beneath it. The next one is white touchdown zone lights. These give depth to the pilot's perspective view of the runway and mark the 2,500 feet long touchdown zone. White crossbar, 100 feet wide, tell approaching pilots whether the aircraft wings are level for a touchdown. So it's here. Sequence lights. Sequence flashes lines of white strobe lights illuminate in sequence to guide the pilot's eye towards the runway center. So you will see this long line, usually 5 to 6 a pair, guiding the pilot's attraction. The red approach light mark an undershoot zone 1,000 feet long in which approaching aircraft should not land. So this part is really close to the runway, but it's red, and it cautions the pilots that it's not part of the runway and they should not land on it. The threshold lights, we're going to talk about threshold in another video about runway markings, but threshold lights may be bidirectional, showing green to pilots landing and red on reverse side, marking the runway end for pilots taking off. So when the pilots enters the runway taking off, they will see green lights. If they're approaching at the end of the runway, that they might run out of the runway, they will see red lights. The visual approach slope indicators, VASIs, we just talked about it. You can go to about 5 minutes earlier in the video to review the VASIs and PAPIs. The white 200-watt center lights we just talked about, and the white runway edge lights as well we just talked about, but here's more to point out, that it's visible through 360 degrees and able to withstand the impact of stones hurled by jet engines. So actually it's not only the runway edge lights, but all the lights that you see on the runway, on the taxiway, and in the airports are special lights that should be able to withstand, stones hurled by jet engines. Okay, so that is it about airport lighting. We covered taxi lightings, runway lightings, approach lightings, and also really important visual glide slope indicators lighting system. So those two lighting systems are for most important lighting system in major airports, and they allow pilots to fly safely during nighttime. That's why you will see there are lots of flights happening during night, and the invention of the lighting system really contributed to night flying, especially to these international flights, where, for example, you're flying from North America to Europe. You can choose to depart at night and arrive in the morning. There are also flights departing on January 1st from Europe or from South Asia that arrives in North America on December 31st, which is quite interesting. But all these flights are possible to exist right now because of the invention and the safety operation of night flying and of all the lighting system. Without any lighting system, they won't be able to exist, and night flying won't be possible. So stay tuned to other videos, and during the club meeting in January, we're going to actually talk about More professionally, the lighting system